So let us summarize the cast rule here. I've got my Cartesian plane and the four quadrants. I know that at the positive x-axis I'm at 0 degrees. The y positive axis is 90 degrees. The negative x is 180 degrees. The negative y would be 270 degrees, and then we're back to 360 degrees. So I'm just putting a comma there. 360 degrees could be here. So this will just help me divide my angle measurements into various values so I know which quadrant I'm looking at. And then by cast, C goes in the quadrant 4. All three are positive in quadrant 1. And again, we're going in that counterclockwise direction when we're spelling the word cast. All right, so the cast rule tells us which trig ratio is positive in that quadrant. So in quadrant 1, we have the letter A, so all three trig ratios are positive there. In quadrant 2, we have the letter S. The sine ratio is positive in quadrant 2. The tan ratio is positive in quadrant 3, where we have the letter T. And the cosine ratio is positive only in quadrant well, it's positive in quadrant 1, but only it is positive in quadrant 4. Sine and tan would be negative in that quadrant. Okay, so looking at our example 3, determine whether each of the following will be positive or will be negative. So I have the angle 152 degrees, and I'm taking the sine ratio of that angle. Well, 152 degrees lies within our second quadrant because 152 is between the 90 and the 180, so it lies in the second quadrant. My sine ratio is positive in that second quadrant, so this would be a positive trig ratio. If I put that in my calculator, I'll get a positive value. The cosine of 215 degrees. Well, 215 degrees lies between 180 and 270, so it's in the third quadrant. My tan ratio is positive in the third quadrant, which then means that my cosine ratio and my sine would be negative. So the cosine of 215 degrees will be negative. The tan of 140 degrees, well, 140 degrees lies in second quadrant. Only the sine ratio is positive in second quadrant. That means my tan ratio will be a negative value. So hopefully you're catching on to this. Try the next 5 examples here, and then put the video on pause. And then after you've tried them, check your work with mine. Okay, cosine of 300, that's the fourth quadrant. Cos is positive fourth quadrant. 245 degrees is third quadrant. Tan is positive in the third quadrant. 295 is in the fourth quadrant. Sorry about that. The 295 is in the fourth quadrant, and only cosine is positive in the fourth quadrant, which means sine will be negative here. 128 is in the second quadrant. Sine is positive. That means cosine will be negative. And the tan of 315. Well, 315 is in our fourth quadrant. Cosine is positive, meaning tan is negative there. All right, moving on to example 4. If the terminal arm of angle theta in standard position is in the third quadrant, so this angle is going to be between 180 and 270 degrees, determine the value of the principal angle for each. So I know the value of my angle has to be between 180 and 270. So if I go ahead and solve this as I have usually, I'm going to do the inverse function of sine on that trig ratio. Now notice my trig ratio is a negative, which makes sense because in the third quadrant, sine should be negative. But if I put this into my calculator as it's written here and solve for my angle theta, the calculator spits out a value of negative 36 degrees. Now, negative 36 degrees, if I graph that, remember negative angles go in that clockwise direction. So if I were to sketch this, I've got my Cartesian plane here, it's telling me it's finding the angle, showing standard position here, the angle going this way. Now that does not lie in third quadrant, first of all, plus it's not a principal angle because it's not between 0 and 360. The coterminal angle to that one could be found by doing 360 minus that 36 degrees. Now 36 degrees is the related acute angle. That means that I can construct the angle I want by drawing the terminal arm in that third quadrant with a related acute angle of 36 degrees. So that means when I go to find my principal angle starts at my positive x-axis, heads all the way around to, sorry about that, to that terminal arm. So to get that value, that theta, is really equal to 180 degrees plus 36. So for anybody who relies on their calculator just to spit out an answer and that answer is the right answer, you got to do a little bit of work. I'm sorry to tell you here, you cannot just go with what the calculator says. So that's going to give you 216 degrees as your angle in standard position, the principal angle lying in that third quadrant. So that is your final answer there. All right, try the next one. Again, we're in the third quadrant, so cos should be a negative value, which makes sense, but I do have a negative here. Solve for your theta, see where that lies, and see if you can figure out how to get the theta that you actually want in the third quadrant. Okay, if I put that in my calculator tells me that theta is equal to 129 degrees. And I'm just rounding to the nearest angle, by the way, like to the nearest whole number. There are decimals to this, but it rounds up to 120. Is it 129 or 128? I better recheck that. Okay, that did round to 129 degrees there. So that is not in the third quadrant. That one's in the second quadrant. So if I sketch that one in standard position, I'm going to be tight for room here. Let me move that. Put my axes over a little bit here. It's telling me this angle right here in standard position, that one in the second quadrant, not in the third quadrant. My related acute angle could be obtained by doing 180 minus the 129. So 180 minus 129 gives me a 51 degree related acute angle. So for those of you who like to work with that related acute, that's what we have. My angle in the third quadrant then also has a related acute angle of 51 degrees. So the theta that I actually want, which I'm going to do in red here, theta would be 180 degrees plus that 51 degrees, which gives me 231 degrees. Okay, so that takes me all the way around to that third quadrant angle. Now the other option there, another option, if you don't want to find your related acute angle, these are symmetrical. This 129 would be equivalent here as well. This would be negative 129. So another option would be that I could take my theta and obtain it by doing 360 degrees minus the 129 degrees, which also gives me the 231 degrees. So whichever one makes more sense to you based on what you've been doing so far, go with what works for your brain. Do it, okay? The tan, now the tan here is a positive value, which in the third quadrant tan should be positive. If I put that one in my calculator, it's actually going to give me the answer of 73 degrees. It's giving me the answer in the first quadrant. So my principal angle being 73 degrees, which means my related acute angle is 73 degrees. So when I solve for theta, I get 73 degrees, but that does not lie in the third quadrant. The one I want in the third quadrant actually goes around to here, and its related acute angle is 73 degrees. So my theta that I actually want here should be 180 degrees plus the 73 degrees for a total of 253 degrees. Okay. Whew. So here's that's where the cast rule comes to be quite important, and it becomes even more important with example 5. Solve for the angle theta if theta lies between 0 and 360 to the nearest degree. So my sine of angle theta is 2/5. It's a positive value. 2/5 is really 0.4. I know that the sine is positive in quadrant 1 and in quadrant 2. So to have a domain here between 0 and 360 means I actually am going to get two solutions to this. I'm going to have the case where I solve this for my theta by doing the inverse function of sine on that 0.4. And I get about 20, we're going to the nearest degree, that's going to round up to 24 degrees. Okay, 24 degrees is here. So that's my angle in standard position here. This is 24 degrees. I also have the option over here where the related acute angle is 24 degrees. So one answer is 24 degrees because it doesn't tell me which quadrant I'm in. I've got multiple options here. Or I could be at 180 degrees minus that 24 degrees, which gives me 156 degrees. So my other option. So there's two solutions to this. I've got this solution and I've got this solution. They're both correct because they both fit within this domain. You can check this on your calculator. Now, we've rounded these angles, so mind you, there will be a bit of a rounding error here. If you, this is just checking, you don't have to do this. If you do the sine of 24 degrees, sine of 24 degrees on your calculator, you get approximately 0.41. Okay, approximately 0.407. Okay, if you do the sine of 156 degrees, you also get a positive value. 156 sine, oh, look at that. That's also equal to 0.407. Okay, so there's two answers within that domain between 0 and 360 that when you put it into the theta, when you solve it, put it in here, you get the left side equaling the right side. All right, continue on with these. Try solving cos theta equaling 1/4. Cos is positive in the first quadrant and the fourth quadrant, according to CAST. I should get two answers for my angle. One would be between 0 and 90. The other one is somewhere between 360 and, or 270 and 360. And as I said, continue on with these, see how you do, and then I'll put solutions up for you to check. Okay, check your answers for part B here. Theta 1 was 76 degrees, theta 2 ends up being 284 degrees. That puts it in the fourth quadrant. The tan is positive in the first quadrant and the third quadrant. The calculator spits out the first quadrant answer of 59 degrees, but we know there's a second answer of 239 degrees, which the related acute angle is 59, so I just added that onto 180. All right, when I put this one into my calculator, I'm going to get a negative angle for that. We get negative 35 degrees. So we've got a little bit more work with these ones to do for most of them to come up with our answers. Check your answers for the last three. I strongly recommend that you draw diagrams for these to help you organize the information, and then you don't have to try and memorize something that's a little bit more abstract.